Welcome to the podcast. Today we're delving into some fascinating insights from the world of machine learning, particularly focusing on a framework known as DeepSeek. Now, if you've ever wondered about the intricate dance between communication and computation in training AI models, you're in for a treat. So let's start by discussing the profiling data that has been released. This data gives us a backstage pass to understanding how models like DeepSeek optimize their performance. Think of it as a behind-the-scenes tour of how AI works when you're not looking. It's all captured using the PyTorch profiler, which is a neat little tool for visualizing what's really going on under the hood of your AI systems. To give you an idea of how these processes are structured, we have training profile data that showcases overlapping strategies for both forward and backward passes. Picture this. Deep learning can often feel like a juggling act between computation and communication. In this case, we see a strategy called dual pipe, which utilizes multiple layers of mixture of experts, or MoE, designed to efficiently handle this juggling. With their setup, a balanced configuration of techniques for training, DeepSeek aims to deliver optimal results. Now, it's interesting to note that while monitoring these operations, they simplified the profile by not including the PP communication. Why? Well, sometimes too much detail can cloud the more significant insights, and simplicity can breed clarity. Let's pivot a bit to the inference stage, particularly the pre-filling process. This stage employs another configuration, which operates on a batch size of 16,000 tokens per GPU. Just let that sink in for a moment. It's like having thousands of conversations happening simultaneously without missing a beat. They use microbatching to balance the workload evenly across the GPUs. So, if one microbatch is working on one part of a prompt, another could be handling a different part at the same time. It's like having a group project where everyone knows exactly what to do, synchronizing without stepping on one another's toes. And while we don't have the decoding profile data ready just yet, I can share a little about that too. The decoding process closely mirrors the pre-filling setup, employing a larger batch size but managing communication slightly differently. The clever trick here is that, while the communication runs, all the GPU computing resources are freed up, ensuring maximum efficiency. Now imagine applying these methods on a larger scale, handling massive prompts and requests in real time. It raises so many questions about how we can improve our AI interactions, doesn't it? Before we wrap up, let's reflect on what we've learned. From understanding the balanced complexities of training with MoE to the efficient communication strategies in inference. What stands out to me is the elegance in the design of these frameworks, each choice made with the purpose of optimizing performance. As we look ahead, I encourage you listeners to think about how these advancements in AI could reshape industries and our daily lives. How can we harness these powerful tools to dive deeper into artificial intelligence? What possibilities could emerge from refining how we approach communication and computation in machine learning? Thanks for tuning in. We've just scratched the surface, and I hope you're as intrigued as I am to see where this technology will lead us next. Stay curious, and until next time, keep exploring the wonders of AI.